alias, it's here.
Right there. Okay. Oh, I see. Okay. Interesting. So we're creating an alias layout and then indexing into it. Let me look at the layout code really quick. I gotta familiarize myself with what the call interface does there.
Yeah, so that's very weird because if I move this part of the code a bit up before those instructions, it doesn't bug anymore. It doesn't crash. If I move it here. So, and this is just
Hmm. Try removing on line 273 and 274 the
yeah,
assign.
yeah. So I did this because I thought that it could help, but it doesn't. Oops, I have some errors with my keyboard. I thought that it will help. It will help, but it doesn't. So I saved the file. Look, I can rerun the debug too, but we see that we still have the error. Do you want me to rerun the debug?
No, that's okay. That's okay. I think the stack would probably be the same. Before printing
Mhm.
index chords 2. So chords 2 prints the int tuple just fine, and then it's only when we are inside of the subsequent print statements. And it looks like earlier we have this layout. Um, what's going on here? If you like assign the results of gate set 1 qubit layout, that call method to a variable and then print it, does it still get mad?
Yeah, yeah. Um, so this, for example,
Yeah, yeah, I'm just wondering if
yeah, that will also crash.
that still crashes.
So I can rerun this. What is it? Debug? Yeah, just uh, yeah, should be good.
And just dummy check the layout is three-dimensional, yeah?
Yes. Tip. If we look at the definition,
Yep.
it's,
Looks good. And then number control bits is greater than one number, circuit number control gates. Two, two. Okay. So that all looks like it should be fine.
yeah,
Um,
that, yeah.
sorry, go ahead.
No, as I said, that's really weird. When I move this up, it doesn't crash. If I put this, for example, I will just copy it. If I put it here, I saw that it didn't crash anymore.
Gotcha.
And yeah, and so this is, I would put PT again.
Yeah, same spot. Run GPU not extracted. It's in GPU examples. Mojo. Yeah, and it's a TC malloc call. What is the interface that it's actually calling there? Alex small sampled hooks per thread. It's well allocated. Okay, this does look like a compiler bug to me. What happens if you bring those alias definitions into this method? So like instead
Inside the function?
yeah.
Okay. So all of them does that too?
Probably just the layout.
Yeah.
And
So
right now I'm just trying to go
I
ahead. Sorry.
tried that, yeah, before. I think I tried it. It still crashed. So up and just see when it's used here and after. Should be good. And maybe you only need to read to run the debug, but it takes more time. So yeah, it still crashes before printing index card. we define the thing here, and then it crashes.
And
Also, I try to save this inside the variable. Also, it is still crashed. Uh,
okay, one sec. Let me go
okay,
my code,
that's
look up and see what potentially could be going on here. That alloc to me looks like the int.
Meeting is being recorded.
That alloc to me looks like the int tuple alloc. So it's probably getting like a handle to something bad, but what could be causing that?
I will rerun I will save the index somewhere. I'll count to print the count to up. So I will save the int tuple in a variable. Uh, here. Yeah.
Okay.
Oh, use
Uh,
and did I not save? I didn't save the file. It's such a weird bug. I don't want to take all of the time available. I can still not use this mapping and do the mapping myself, probably. Oh,
yeah. Oh, did it get further?
I guess yes. Why? God to say yeah here. But you see, what's really weird is that it's showing 8. It's the 000.
Yeah. Yeah.
It did that also last time. That's the weird thing.
So on the LLDB, uh, yeah, do backtrace BT. Oh, that's a big
Yeah,
error.
because we reach farther, I guess, and it's calling methods, it's calling everything
Yeah.
now.
Okay. Let me see here. This is in a free pointer method. In LLDB, could you do I think it's up U is what brings you up in the stack.
Here and that up you.
Just U.
Okay, you. Oh,
Or
yep,
up.
up. Okay.
And then up once more. One more time. Oh, and that's in a list. Do you have a list in your code somewhere? If not, it might be an internal to the layout tensor.
I do have a list, but it's where is it's this is that is it in this file? Because this is what defines this, but I don't use, so at least here I don't use this in the kernel. I just use this for the print here. Yeah, but that's probably another list. Uh,
Yeah, potentially.
so here, do they have a list here? I don't have a list in this file.
No list there either. Okay. I'm gonna make the same suggestion of like bring the list into the method and then make it variable instead of an alias. Um, I think you should like, conceptually be able to keep it as a variable, but
Yeah.
it looks like there's something weird with like lifetimes and aliases.
Hmm. Okay. So yeah, it's before loop. Where is before? I just don't know where we are here. Oh, it's oh yeah, we are in the qubit wise. Yeah. So I put the list inside the, yeah. Uh, but it's weird because we don't use it. I don't know. So the list. Ah, yeah. What I noticed maybe. Oh, it seems to work.
Okay.
Sh-
Yeah,
Have
let's
I
check
done?
if we're out of bounds and everything.
I seems fine.
Excellent. Okay. That is for
Thank
sure
you.
a bug though. So what would be super helpful is if you could what's the maybe Hodge or
I,
Caroline?
I, I can commit. Yeah, I can do a commit. And so what we saw is, yeah, because it's a big data, a lot of code. So I cannot. It's really hard for me to. Yeah.
Yeah, yeah. I think let me make a note. I think I might be able to tinker with this in a little bit. So I think the two issues were one, we had a we were trying to pass like an inline int tuple as an argument to a layout tensor, and I was unhappy about that. The resolution there was to bring the layout tensor into the method and then also store the int in an intermediate variable. And then the list issue is that we had an alias list, and then that appeared to be like a double free or something like that. Um,
Because it's a list of lists, so maybe that's why.
I think it was more so that it was like static. So like the lists in Mojo are very dynamic. And I don't know how the compiler handles it when we try to hand like this dynamic container or evaluate a dynamic container at compile time. I know there was
Okay.
a similar issue with aliased strings that we saw recently. So I'm skeptical that we're handling that correctly. There's probably something weird there.
Okay. Oh, thank you so much for the help for helping me debug this.
Yeah, absolutely. Sorry for the bug. I'm gonna make a note of that here and see if we can get that resolved.
It's okay. Thank you. I will stop the
Thank you,
sharing.
Thomas.
Yeah,
Thanks
thank you,
for playing.
Thomas. Thanks for stopping by.
Austin, would it be helpful for Thomas to create a GitHub issue, or do you think you have enough info?
Yeah, I think Thomas, if you could create an issue, just um, if you can just, I mean, if you can pare down the code, go for it. But don't
Yeah.
spend too much energy on it. Like you said, you had a lot of code there, and I have a note here of the actual issue. I can see if I can go create a min reproducer as well after this.
I will try to do a short issue, yeah.
Awesome.
But after
Thanks
the
so much.
hackathon. Thank you.
So, thank you so much.
All right. Whoa, we got a big crowd here. Who's next?
Yeah, who has a question?
Hey, this is Pradeep. I can go next. If I don't know if I was in the queue first or I think Darren was before me, um, but I can go.
Yeah, there isn't a formal line. I had asked if folks wanted to like raise a hand if they had a question, but I haven't seen any hands go up, so I think you're okay
Yeah,
to
go
go.
for it.
Okay. All right. Sorry, I can't come on camera. It's too
That's fine.
hot
No
and I'm
worries.
sitting without a shirt. So,
No worries.
okay. So let me just share my screen and give some context. So what I did, I just want to make sure that I'm not way off the mark here. So what I did was essentially build a NMS kernel for non-max suppression in Mojo first. So, and I tried to do it using layout tensor, and I got into a lot of issues. So I asked Cursor to kind of do a CUDA equivalent. And then from the CUDA equivalent, I kind of did the pointer-based kernel in NMS, in Mojo. And then it works fine. Then I asked it to benchmark, and the benchmark looks something like this. It's like 7 times faster than CUDA. Is this legit, or am I missing something somewhere?
I mean, I'll take the win. Let's see. Let's look at the code. So where you actually like launch it, one thing that we want to check out for is that you're calling context synchronize.
Yes. I think, uh,
So there's the fast NMS. Actually, if you could share the benchmark code, I think that would be
yeah, where's my benchmark test? Yeah.
great.
Can you see this? Is it too small? Should I?
No, I can zoom in. Yeah, I got it.
Okay.
Um,
So I put it for 4096 boxes, 10 trials, and then, I mean, this is all cursor generated, a lot of vibe coding, sorry.
no, you're good. That's the future, man. Okay. After line 57 there,
Okay.
what you'll probably have to do is call ctx.synchronize.
Okay.
Yeah, there you go. Cursor's got it. And I
This
actually
whole
would,
Vim and cursor integration is not the.
yeah, they fight each other sometimes. And then after line 55 as well. So before the perf
Here?
counter recorded, yeah, just immediately after that. So what that's effectively doing is just synchronizing the stream. Um,
Okay.
it just synchronizes between the CPU and GPU. So then the perf
Okay.
counter there will actually like start counting as soon as the kernel's launched and then stop counting after the CUDA driver and CPU agree, hey, we're done launching the kernel. We can time it. Um,
Okay. So let me just run this and see if it actually. Uh, I'm just trying to, I mean, I can do this all myself. I'm just trying to see how good you know, the editors are getting with
yeah,
the new language like Mojo. So I'm like trying to.
yeah, they're okay. There's definitely not much Mojo in their training data. They hallucinate quite a bit.
Okay. So with the synchronize, it is almost on par with CUDA,
Okay.
right? Average time is 7.3. This is 7.19. Okay, that that makes sense. So if I don't do synchronize, what am I missing?
Yeah. So if you're doing synchronize, what's effectively doing the CUDA API, or more specifically just kernel launches on NVIDIA, are asynchronous. So like from the CPU side, you're effectively like lobbing a kernel over the fence to the GPU and saying
Okay.
go run that. And then on the CPU, you just immediately start executing the next line of code and continue executing onwards until you call context synchronize. So contexts are very analogous to like streams in CUDA.
Hmm. Hmm.
Effectively, you're scheduling kernels to run along a stream. And then after you've scheduled a kernel, you need to call like stream synchronize in CUDA or device context synchronize in Mojo. And what that does is just tells the NVIDIA driver, hey, I want to wait for this kernel to stop executing. So then it actually blocks on the CPU and you don't continue executing code. So previously, you're effectively like starting kernels and then saying start, stop the stopwatch without actually waiting for the kernel to finish executing.
Ah, I see. I don't know if are they doing, can I just see if he's actually doing a synchronize in CUDA?
Yeah, let's check it out. I mean, if you're getting like consistent timing, it probably is, but let's see.
Yeah, they do some sync. Yeah,
I
there it
see.
is.
Yeah, so they use events, which are a little bit more precise. It's like lower level in the driver, but it's the same idea. You're effectively on the stream saying, here's the start of the time, here's the stop of the time, and then what's the length of that span effectively.
Okay, gotcha. All right, so this is super helpful. Thank you. Thank you for correcting my benchmark. And now I can kind of use this with YOLO V10 and see if I
Awesome.
can get a faster overall result just compared to like native V10 YOLO with the NMS on the CPU.
Beautiful. Excellent. I'm excited to see YOLO and Mojo. Can't believe we're on
Yeah,
V10 already.
let me see if I can actually get it done. I don't know if I'll have the time to get it done. It's a lot of code. So hopefully Cursor should help.
Godspeed.
All right. Thank you. Cheers.
Awesome. Thank you.
All right, who's up?
Mohammed?
Hi. I don't have any technical issues like others. By the way, can you hear me all right?
Yeah, we can hear you.
Coming through.
Okay. Okay. I don't have any technical issues yet, like the others. I just wanted kind of your personal opinion on what you would like to see built.
Yeah, so we actually
If
have a
that's the sort of thing you can share in office hours, or if that's
I don't know if it's my Wi-Fi, but you're breaking up a little bit on
You're picking
my
up on
end.
that too.
But I was just gonna say there is a doc. I can put the link in the chat in our forum here that has a list of projects that we would love to see folks build. So let me drop that link in the chat. So definitely recommend checking that out.
Yeah, I saw that. But I guess I was hoping if Austin maybe could share his personal uh, project recommendations or something, or if there are any.
Yeah. Oh man, that's a great question. So we've primarily been focusing on LLMs. Um, but there, as you know, there are a number of other like really interesting models to be built. Especially those that are, either diffusion models or uh, multimodal models. Those are ones that you're kind of actively in development, but would be awesome to see other folks implement. So my suggestion, if you're kind of interested in like model development, adding, Flux is a complicated model, but that's one that you could do. Bagel is another interesting model that kind of allows you, I think that's the one that allows you to like edit images. Really like, the more out of the box, like not really standard Llama DeepSeek kind of models would be really interesting to see implemented. But if you're more interested in like the lower level stuff on the kernel side, you know, uh, I think we have quite a few kernels in like the standard library, but I still think it's useful from like an educational perspective to go through the process of tiling for like matmul, or even looking at flash attention or like the new flash MLA variant for like DeepSeek R1 models could be kind of interesting. Um, yeah, I guess like where's your area of interest? Do you have any ideas?
I'm kind of all over the place since the hackathon started. But the more I was diving into the code base, I realized that a lot of the kernels have been implemented. So I don't think I can do anything new from, from like there's nothing new to be done there. So yes, I was also thinking towards implementing models. So that would primarily be towards the Max side of the stack, right?
Yeah, that's right.
Or we can also write our own kernels and use them as a custom op in the models.
Yeah, exactly.
Right. Okay. I'll look into this then. Thank you. Thank you for your insight.
Yeah,
That's it.
yeah,
Thank you. Any other questions?
Yes, I can go next if you can hear me.
Yep.
Yeah.
Yeah. So, yeah, this hackathon is my first interaction with the entire modular stack. I'm going through the code base and it's amazing. Great work done there. So I was thinking about implementing the diffusers pipeline, stable diffusion. And after going through like the current way max serve and like max generate work, there is no like image generation pipeline defined, which is fine. That's something to like be taken care of. But there is like another issue where diffuser pipeline doesn't use the config.json files that like other pipelines use. They use like a model index.json, I think, which is like another totally different way of reading a model from the configuration. is there a workaround around that to like be able to use the different bring together the different components of like the diffusion model without a config.json, because that's like embedded deep into the Max how it like reads the configurations.
Yeah, that's a great question. I know at one point we had the fusion models on CPU supported. So I'm wondering if there's some like carryover code from that. Let me see if that's still in the code base.
Yeah, I'm catching this office hour from like outside, so I don't have access to my laptop. Sorry about that. Otherwise, I would have brought that up myself.
You are good. Uh, Let me see. I don't know, Hodge or Carolyn, do you know if we still have those CPU diffusion implementations?
As far as I'm concerned, I didn't see any like image generation pipelines, but I'm new to the code base. Obviously, I could have missed.
Yeah. Yeah, let's see. I know, so yeah, we had implemented them initially on CPU, but I think that might have been before we like heavily invested in the Graph API. So there might not be kind of like modernized code to do that. Um,
Yeah, but if there is some, I could definitely use that as like a way to implement it for the graph.
yeah. Yeah, it looks like we might have ripped that out. So I don't think we necessarily have that existing code for you. Um, my suggestion is the interfaces for the different pipelines that we use is available. With some jury rigging, you might be able to build your own pipeline that actually interprets that config file. And then if you wanted to like natively integrate it with Max, you could monkey patch the load pipe. I think it's load pipeline. Maybe,
Yeah, I know what you're talking
yeah.
about.
Yeah, so
Yeah.
that would be my suggestion. It doesn't look like we actually have something already in the code base for that, so it looks like something you have to build.
Given given the fact, do you think it's possible to do all this like monkey patching and like implementation in maybe 1 or 2 days?
Uh, I think so.
It sounds like a lot of changes to like the configuration reading and stuff.
Yeah, I mean, my recommendation is to the best of your ability, like just write independent code from the existing config parsing. Um, and that may also include, just like creating a watered down entry point. So creating like a really simple Python script that targets the entry points that would actually like get you to your pipeline. I guess really what I'm saying is my suggestion is to almost like fork off from the existing pipelines code for this new pipeline that you're creating.
Right.
Probably give you like a little bit more agency to write, what you need to write so that you're not spending a bunch of energy trying to like fit it into the existing stuff.
Yeah, that makes sense. Thank you. Let's see what happens. And I'm probably going to see you in the tomorrow's office hour, given
Yeah.
how things are.
Yeah.
Yeah. Thank you very much. Thanks for your help.
Yeah, thank you.
Yeah.
Thank you. Any other questions?
Question for Matthew in chat. What are some ways we can contribute and participate with Mojo?
Is that, do you mean it's in terms of the hackathon, in terms of like what we would like to see people build? I would definitely recommend checking out that link I shared. I'll share it again because I don't know if it gets shared if you just joined, but there's a bunch of examples of different kernels and models that we'd love to see people build for the hackathon. So I definitely recommend starting there in terms of the hackathon.
We also take open source contributions if you want to help clean up our code base.
Yeah, I'll also link the contributing guide for Mojo and for the kernels.
Perfect. Love to hear that. Thanks, Mohammed. Mojo looking for anyone to contribute to the site documentation. That's a good question. I think we do take contributions on docs, right? Right, Caroline?
I think to some areas.
Yes. So the docs aren't open source, so we don't take direct contributions to them. But I think that we do have a button there where you can suggest changes to the docs, and then that'll go to the docs team, and you can do some things there. We just open source some internal engineering design docs, and so that's kind of the first release of docs that are being open sourced right now. But depending, but like, you know, if it's like an API doc, those are generated, I think those are partially generated from the code, so you can contribute to the code to fix those up.
Yeah, cool. Thanks, Hodge. Any other questions, folks? Feel free to unmute, raise your hand, whatever.
Not developer here, but actually just curious to learn what is overall about GPU programming and how to use it. Um, can you describe when it comes to Mojo and Max, which part is open source, which is not, and how do you describe the open source aspect of the whole project?
Hodge.
Yeah. So if we like, there are some major components for, if we start from the bottom with Mojo, at the base of Mojo, we have the runtime, which is, you know, just like all of the libraries that are required to kind of load Mojo into your system and to run it. And then there's the compiler that sits on top of that, which will compile um, your program down. Both of those components are closed source right now. And a big part of that is just we're trying to iterate on the language, and it's changing really rapidly, and we need to make sure that it's meeting the needs for what we're doing internally, but also just be able to push fixes a little bit faster. Those are the only parts that are proprietary right now on the lower side of the stack. And then on top of that, we have the standard library, which is actually the source of a huge amount of the functionality for Mojo. So we try to keep the language as thin as possible, and then push as much functionality as we can into the standard library. So if you think about like the SIMD data type, where for a lot of languages that would be an intrinsic data type that would be handled by the runtime and the compiler, instead that's actually entirely implemented as part of the standard library. So that's open source. We've been accepting contributions for that for about a year now, I think. And we've accepted like 1,000 contributions to date on that. And so that's actually been a lot of community contributions and a lot of work that's going into that. And then we recently released our AI kernels and our graph library. And so these are the more advanced high performance kernels that are targeting your NVIDIA and your AMD hardware. It's where you're getting your matrix multiplication, your softmaxes, your kind of like all of your neural network functions and ways that you can, you know, high performance math and ways that you can build the graphs. That's all open source too. And so the majority of the stack is open source. And our intention is to open source the compiler and the runtime before the end of next year. And you know, but that's we don't have any date that's more specific than that. But we're really committed to, you know, we really believe that Mojo is going to be and Max are going to be the future of how we program GPUs and how we do AI programming, but we want to make sure that we get it right. And so so we're kind of like progressively open sourcing the pieces. So does that answer your question? And everything that's open source is Apache 2 with LLVM exceptions.
Yeah. So if someone, like for example, want to write a more higher level scientific kernel, is the framework already ready for that kind of thing
Yeah.
for actual use?
Mm-hmm.
All right, thanks.
Thanks, Hodge. All right, any other questions?
Yeah, sorry, I was just a little bit late to the hackathon, but I had an idea that I started working on. I didn't know if I could get like feedback or whatnot on it.
Sure. Hit me.
Yes, so the idea is building a transpiler to convert CUDA into Mojo.
Hmm.
So I don't know if I can screen share or not. It might be disabled. Can I screen share?
Yep, I can see it.
So basically what I have right now is this is just from my CUDA documentation. It's like an example kernel. And I'm creating this JSON file then where it has like 10 test cases where it just tests 10 random inputs and gets the output. And the idea is then you would generate the Mojo code. So you would have this as the input. This is the input to the Mojo, or this is the input to it'd probably be Llama to then output the Mojo code. And then you test it against the outputs that CUDA got. So I guess I mean you can stop me. What I'm thinking is just uh, launch a Llama instance on Lambda, and then just have it print out. Basically, the prompt just prints out the Mojo code, and then just try to run the Mojo code and run it against each of the test cases.
Yeah, I think the scope of the hackathon was like intended to be more like Mojo kernels and Max Graph stuff, but I think this is cool.
Gotcha.
I'd I'd like to see this happen.
Yeah, that seems awesome. Yeah, I mean, the main focus is Mojo kernels and Max Graph architectures, but that doesn't mean you can't submit something else. It seems like an awesome project.
Gotcha. I don't know, do you have any input on how to build it or?
Yeah, so is the goal to like make an LLM be the kind of transpiler for you?
Yeah, that's the idea. Is use Llama.
Okay, yeah. So the main challenge you're probably going to run into is that like there's not much Mojo code out there, so there's likely not much Mojo code in the training data. So you may have to fine tune it with some like examples. Um, I don't know if there are like public like one-to-one, here's a CUDA kernel, here's a Mojo kernel data sets that you could find for that. The alternative is to just context stuff and like put a few examples of transpilent, like a example CUDA kernel and then a Mojo kernel, and then in the prompt itself to the model before you prompt it to like translate whatever you have. Um, Include those examples so that it has that context in its attention window, like when it makes the transfer. So I think that the challenge that you're probably going to face in doing that is strictly just that, like the model doesn't really know valid Mojo syntax. But fine tuning, Q LoRa, anything like that should be able to, or just I guess general LoRa should be able to kind of unstick you there.
Gotcha. And then I haven't used Lambda before. Can I run that on Lambda or not?
Good question. Is this AWS Lambda or is this Lambda Labs?
Lambda.
Yeah.
Labs. You should be able to. I mean, it's just like a VM with a GPU attached.
Yes.
Yeah. Yeah. So that should work.
All right.
Cool. Thanks, Tyler. All right. Any other questions? Oh, I see one from Thomas. Transfer static CPU to the GPU. There's constants of execution defined as recommend to use a method like map to host. There's more efficient to use a kernel function to initialize buffer using multiple threads. Maybe are there other options for initializing static data to the GPU? Great question. So the naive way that I would do it is just have a device side buffer. Well, I guess, yeah, allocate like a device side pointer. And you can wrap it in a layout tensor or your tensor wrapper of your choice, modify the contents, and then just copy it up to the CPU via the driver API. So like I guess it's technically device context. So device context enqueue transfer, I think is enqueue copy, queue transfer copy or something like that. Yeah, enqueue copy. So that'll get it up to the GPU. That'll still be in like a mutable buffer. There is the notion of like constant memory in the NVIDIA driver. And I'm fairly certain we have support for it in the Mojo language, but I forget I forget what the syntax is or how deeply that's supported. So my suggestion is just to, even though it's static data, just treat it as if it was dynamic. Initialize a buffer on the CPU and then use context and queue copy to get it from the CPU to like a pre-allocated device buffer. Does that make sense?
I can probably talk it easier. Thank you for the response. Is enqueue copy faster than doing this map to host thing?
I think so. I think so. I think they're both pretty similar, but my just general assumption is that with map to host, there is some amount of inherent like synchronization between modifying the GPU mapped, or I guess CPU mapped
Yeah.
memory of the GPU. Whereas if you can just enqueue a mem copy, like I think a single one-time copy up to the GPU is likely faster.
Okay, thank you. There was another question before me. I'm sorry for, I think, yeah. There's someone else that asked a question, Mohammed. But thank you for your response.
Yeah, you bet. I think Mohammed been
It looks
commenting
like,
this
yeah,
discussion.
looks like Mohammed asked a question in the chat.
All right. Let's see. Someone's got B200s coming from beginner level PyTorch background. I never really cared about the GPU I was running until I got an Oh no. Really take full advantage of the latest hardware. What should we be doing different? Let's see. Yeah, now the question is how to really take advantage of the latest hardware. What should we be doing different? So yeah, are you having like technical difficulties getting on the host itself?
I think Mohammed is having audio issues, so he might have to just respond in the chat.
Oh, okay.
Mohammed, are you able to hear us? Okay.
Got the email during the office hours. I was not talking about any connect. I was just saying, how is this different from using an 800 for an example? For example.
I see. So like how to take full advantage of whatever architecture it is that you're working with. Yeah, that's a great question. So I mean I think easiest thing you can do, the latest chips have more memory, so you can fit either more model, like more parameters into the GPU, or you can increase the batching that you're sending to the kernels, specifically in like an ML centric world. Increasing the batch size generally is a good thing. It hurts your latency, but improves your throughput. The more recent architectures from like a kernel level have some really neat intrinsics in the compiler that you can take advantage of. So as an example, you can launch asynchronous copies from GPU global memory into shared memory that enable you to effectively pipeline execution of your kernels. And I think we have a few documents describing how like a pipeline mapmel can work. Effectively, like some threads are working on doing the loading and placing tiles into shared memory. Other threads are processing those tiles and actually doing the computation before sending the results back to global memory. The other new intrinsic are the kind of warp level instructions. So you can have like MMA instructions where you do a small dot product on smaller tiles in tensor cores that are like specialized to do those kinds of operations that are much faster than just doing them at the thread level. I think those instructions were introduced in H100 architecture, if I'm not mistaken. So that's another area that you could kind of explore in terms of like fully utilizing the hardware. In B200, they added warp groups, which are effectively two warps that run in conjunction with one another that effectively allow you to have like a larger kind of warp construct in your kernel that enables you to just do more work parallelly that you know is running in sync and that can also share some amount of memory for like faster, I guess, as processing.
Sorry, I don't know why that echoes. I only had one mic on. Yes, Mohammed, I am recording this and I will share the recording afterwards so you can catch up with the full answer.
Yeah, you bet. Thanks for stopping by. Any other questions? Feel free to raise your hand, unmute, whatever.
You can also feel free to share what you're working on. I don't know, do show and tell. If you have a pet you want to show us.
Can you guys hear me?
Yes.
Yep.
Yeah, so my question and my use case for the CUDA kernels is something beyond matrix multiplication. So the H100 is a beast. There is no doubt about that. But in my line of work, I'm more interested in using bandwidth to do some custom operations. So I was wondering, suppose the work is about loading a large amount of data, basically the algorithm is always memory bound, and you do some operation on that and you write out some single result. Like I said, most operations in the scientific field are very memory bound. Would there be any interest if you were in my place to somehow use these new instructions, the asynchronous memory copies, something about work groups, to try to accelerate this? Or are these instructions purely for matrix multiplication and nothing else? So would
Oh
you
no,
try
they
to
can.
explore something like that for custom ops?
Yeah, they're just general purpose intrinsics. I think matrix multiplication is just like, the most common use case that we see in like Gen AI. But the intrinsics are there, and they can be used for whatever use case. Actually, if you're interested, what I can do is go to our public, you can go to the open source repo and just show you or provide you with an example of how we use it. It's going to be a MatMul example, but it can at least give you a sense of like what the interface looks like for you to latch onto it if you're interested to dig into it. Fine.
Okay.
Yeah, so I have a question. Like, assuming you're doing an algorithm, what are the optimization techniques that are available to you that you can use? So, for instance, in CUDA, right? Like you can do naive matrix multiplication. And then if you want to get speed up, you can do tiling or you can use shared memory. Do you have the equivalent of those kind of like optimization techniques in Mojo?
Oh yeah. So anything you can do in CUDA, you can do in Mojo. We compile down to the same PTX. We latch on to the same intrinsics that they do. If you want to tile, use shared memory, either statically or dynamically allocated, anything at all, you can do it. If there's an intrinsic in the NVVM dialect, which is effectively just the MLIR dialect for compiling down to PTX, that we don't have bindings for, there are some examples in our code of exposing a binding to it. So if there's if you find something that we don't have yet, which I think at this point we support all the different intrinsics and have used them all in our kernels. But if you find something you don't have support for, then you're able to go do it. And then if you feel so inclined, just contribute it back to the code base and we can start latching onto it too.
Okay, thank you. Follow-up question. Do you support like multi-GPU capabilities?
Definitely. Yeah. So we have support for tensor parallelism. The Python driver API has support for doing mem copies between different GPUs. We have an all reduced kernel. We're working on, I think, an all gather. Well, I guess we have an all gather kernel, I guess is kind of the same thing. So yeah, both in Python and Mojo, we have APIs to facilitate that.
Okay.
Multi-node, we're still working on. That's something that is in flight, but the multi-GPU within a single node, we have support for that.
Okay, thank you. I'm just familiarizing with the language, so I'm asking teaching questions.
Yeah, for sure. My suggestion is so I'm posting a link for Tornakeo on an example of async mem copies. But more generally, we have a whole slew of kernels in our linalg subdirectory in our open source kernels. So highly recommend checking those out if you have if you're curious about how we handle specific things in the CUDA API. That's a great spot to go. Also,
thank you so much.
you bet. There's also examples too.
By the way, the chat shows mostly this content can't be viewed here. Maybe it's not supported, but I will some of the links I can see, so I'm gonna get the pointers from there.
Gotcha. Okay.
Okay.
Oh, yeah, nice. I just noticed you linked Nabla. I'm a big Nabla fan. I think that's so cool what they're doing over there. Cool. Any other questions? Yeah, keep spreading the good word.
We appreciate it, Mohammed.
We go public.
So so far though, like what kind of use cases have you used in which industries are heavily adopting the language thus far? Like mostly is it AI companies or like across board telecommunication, finance?
Yeah, so far predominantly, AI machine learning companies. And that's, kind of intentional on our part. That's who we've been targeting. the language is, flexible to any domain. And I think in the fullness of time, Chris talks about it a lot, that we'll start to, expand outwards, but we're very, very targeted and focused on AI and ML at this point.
Yeah, because of the tight integration with Python, I feel like a lot of use cases across board.
Yeah, totally. Yeah, we have to be, it's easy for us to get, lost in the sauce and get so excited about all the different things we can do with it, but we got to stay focused as a team. But that doesn't mean, the community can't take it and run with it in other spaces. And I love to see it when that happens. Yeah, for sure, Thomas. You can definitely do anything. Still young language. We have some bells and whistles to add to it, but you can do a lot with it, if you try hard enough, for sure.
How about HPC?
HPC? Yeah, I mean, I would consider ML and AI just to be like a subset of HPC. So the foundations that we're building are pretty extendable to that. I think, HPC also carries with it some notion of kind of distributed computing, which like I mentioned is um, something we're still working on in terms of like internode, but within a node, leveraging multiple GPUs, definitely something that we support. Oh yeah, Caroline, you mentioned that. Oh, sorry, go ahead.
How about like composite, multi different kind of hardware? It should be able to do different kind of hardware in a single job, right?
Yeah, I think theoretically the binary should support it. The challenge with multiple different kinds of hardware, especially in GPUs that we've seen, is that networking is extremely important. And when you connect multiple GPUs together, having them be consistent vendors, even like consistent architectures, is really, really key. But there's nothing stopping you from like running a box with an NVIDIA and AMD GPU with an ARM chip. All of it should work together.
And can it be containerized, like running in a Kubernetes environment?
Oh yeah, yeah.
So I have this question, like, since NVIDIA makes the GPU, right? And they have CUDA, and it's the tightly integrated with the hardware. Do you think Mojo is gonna match the performance of CUDA, given that the hardware is made by a different company?
Yep. Yeah, I think we've actually demonstrated that for specifically like mat balls. We've demonstrated consistent performance with cuBLAS in a couple areas. They get a head start, like they get to
Mm-hmm.
start writing the code before the hardware is available to us. So I think there's inherently going to be some amount of catch up that we're always doing with them. Until we start to kind of get the opportunity to work with them more deeply. But we've demonstrated that our kernels can run just as fast as their kernels.
Nice. So, but can you also work with AMD thus far?
Yep. Yeah,
Okay.
we announced AMD support, right? I'm not leaking. Okay, cool. Yes, it does support AMD.
Nice. Okay, cool.
Yeah, AMD support was a big deal. It was a whole thing. Yeah. So and we support a lot of the consumer GPUs, although not all, like if there are some floating point operations that we still had a little bit of trouble with getting to work.
How about RISC-V?
RISC-V.
Yeah, RISC-V isn't supported yet. That's not on our matrix. But longer term, like we're trying to bring up more hardware architectures, and so we have people working on Mac OS right now. So being able to write directly to the I don't think it's the neural processors. I think it's the GPU processors on Mac OS. So we're hoping that's coming up soon, and we kind of want to use the Mac OS and AMD as a model to bring up other architectures. And so, you know, just like thinking longer term, like further out, like that's an aspirational goal that we have that we're hoping, and we're hoping that, like some of those architectures will, like community members will help us bring those up, because like all of the consumer, like the NVIDIA 30, 50, 40, 50, or 30, 40, and 50 series machines were like all community driven work to bring up those architectures. And the RDNA, I think 3 and 4 were also community contributions.
Yeah, so because the problem with RISC-V, there's not a standard kind of a IR yet, like PTX. Is there any information on what's if there's support, what will be the 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 different layer will be like?
Yeah, we don't. I mean, that's not. It's not. We don't. I don't think that we've looked at. I don't know if engineering has looked at RISC-V, but I don't think it's like on our roadmap right now as something. So I don't. I don't know the nuances to be able to bring that up.
Yeah, I don't think we thought about it hard enough to give you a solid answer to that. I mean, it's a very good point, and it's an engineering problem we'll have to solve when you get there, but we haven't thought hard enough about it.
You have a question about that to follow up on that? Who should I contact?
Hodge, do you know?
Yeah, I mean, probably the best place is to ask in the forum, right? If you go to forum.modular.com, because then, like, the good thing about that is the right person will answer there, but then that answer will also be there for everyone else to see.
Oh, okay, right, thanks.
Yeah.
In terms of barrier to entry, like learning the program, how long do you think it's going to take overall to get up to speed? Like a month?
Yeah, I mean,
For oh yeah, go ahead, Austin.
no, I was going to say, it depends on the person, depends on what level of competency you want to, get at, or what level of, um, expert level you want to be in the language. We're all learning all the time. But if you grind at it for a month, like that's perfectly a reasonable amount of time. It's at the end of the day, you're learning new syntax. If you know CUDA programming, it should feel very familiar to you, or even like Rockham programming. But Hotch, go ahead.
Yeah, yeah, and like I think my experience, and so like everybody who learns Mojo right now is learning it for the first time. And so like when I was applying for the job with Modular, I actually sat down over a couple of weeks and worked with Mojo, and I was working through a machine learning textbook and implementing a lot of the algorithms there. Um, and I felt pretty comfortable working with the language. If you know Python, you're a lot of the way there. If you've ever worked in C++ or Rust, like that informs a lot of what we're doing too. And so you'll pick up a lot of the ideas there, and so it depends, like, if you kind of have an understanding of like generic algorithms and parameterization, either through C++ templates or, through any other language that has those features, like that will help you understand. But really like working through the docs and working through the GPU puzzles, that's entirely tractable. And over the course of a few weeks, you can become very fluent in the language, I think. And even at like the last hackathon, which was a day long, people who had no experience with Mojo they were doing GPU programming by the end of the day. So it's a pretty fast learning curve.
Nice. Yeah. Yeah. Do you guys have any textbook, or is just the online documentation?
It's just the online documentation. The language
Okay.
is changing way too fast
Okay.
to have a printed. Like if we published a book today, it would already be out of date, right? because of the time it takes to go to press. And the language is getting more stable, and we're kind of like dialing into like the core features, but there's still like oh yeah, like these are some rough edges of the language, and like we're working on sanding those down. And so
Okay.
it's changing. We're working our way towards a 1.0. We're
Okay.
almost there.
Thank you.
I do recommend checking out the Mojo GPU puzzles though, as like one reference.
Yeah, and the doc, like for learning Mojo, like the core Mojo syntax, like the docs are really good. Ken and Arthur have been writing those, and they put a ton of thought into how to explain the language and the core concepts and how the examples work. And combining that with the GPU puzzles will just like get you a huge amount of the way there.
Yeah, his son did a great job on the puzzles. And the docs. The docs are just awesome.
Awesome. Any other questions before we wrap up? All right, well, otherwise, feel free to put any questions that you have in the Modular Hack Weekend channel in the Discord or the Modular Hack Weekend category in the forum, and we'll try to get you unblocked as quickly as possible. And yeah, happy hacking.
Thank you.
Thank you. Have a nice day.
you.
Thanks, everybody.
Thank you.
Thank you.